Okay, example 10. So in this example, we're gonna do something a little bit more advanced. We're gonna use this line right here that I've created, and we're gonna make it kind of electric a little bit. We're gonna keep the ends the same, so they are static. So we have a lot of control over this line. We're gonna make the ends be the same position. We're gonna add a noise in between. So how do we do this? Well, okay, we need to think of it first in a couple of steps. So first of all, we have a line here. I've made it the length of 1.4. I'm gonna make it 1. Yeah, let's keep it 1.4, whatever. 1.4, it has 2 points. It has a point in the origo, 0.000, and then there's a point here. There is 0, 1.4, and 0. Okay. So first of all, what I want to do is I want to calculate the distance between these 2 points. Granted, in this case, I actually do know the distance. The distance between these points are 1.4, right? Because this one is 0 in y and this one is 1.4 in y. It don't really change in x and z. Anyway, I want to do it anyway because I want to prove a point. So I want to do this in a VOP, okay? So we're going to use a node called distance. So what we're going to do first, we're going to pipe the line into the first input because we're going to work on the line. And then we want to isolate each point, okay? So we're going to delete the point number 1 because the points have, as you can see here, the points have the values or the ptnum 0 and 1. We're going to delete ptnum 1 in this one. We're going to keep only 0. And here we're going to keep 1. So we have both points separated here. And then we're going to pipe point 0 or the original point that has a value 0, 0, 0 in position into the second input of the VOP. And then our point 1 that is 0, 1.4, 0 in position into the third input actually of the VOP. And now let's dive in here and see what we can do with these points. So as you remember, we had 2 VOPs here called the import point attribute. We're going to import the position for both of these external points. So we're going to import for both input 2 and 3. As you remember, point position for the input 2 is 0, 0, 0, and point position for the input 3 is 0, 1.4, 0. We're going to import both of these positions, make sure they are vector and that they are the important attribute p. Okay? Then we're going to use the distance. The distance takes 2 vectors and it simply calculates how far the distance is between these. Okay? So we're going to calculate the distance between these 2 points with the distance node. This distance outputs a float. Just the distance between them, no vectors, nothing. Just a float how far their points are in between. Okay? We're going to pipe this into a fit. The fit will basically make the distance between these and it will make a value between 0 and 1 because we're going to use distance in a ramp to put a color for the distance. But we also need to know the source max. We do know the source min. The source min is 0 for this, so we can put it to 0, okay? The source max, however, is going to be the position for the second point that we pipe to the third input. And therefore we can pipe the result of the import point here into the source max. This means the source max is going to be 1.4, right? But we do need a component. So vector component, we're going to put that to never mind. We can actually do it like this. Yeah, we're going to pipe the position in here. We get the source max. And then we get a result from this, which is between 0 and 1. And this is, we're going to then pipe into ramp. And this ramp, we're going to, since it is between 0 and 1, we can put it to color ramp and we can output it to color. This means our color of this line is going to be going from white to black. Okay? To demonstrate this, we can put it to red instead and like blue. I don't know. And we can clearly see that it goes from blue to red. Now I actually want to keep I want to keep it from black to white, or from white to black, like this, because we're gonna use the color later in the noise. So for this, we now need more points, all right? Because we only have 2 points now. So how I'm gonna do this, I'm gonna resample this line here. I'm gonna resample this, so I'm gonna make the maximum segment into 86. This means we're now gonna have 87 points. This is a good amount. It doesn't really matter, but you should have a good amount when you put on the noise that you get like some actual detailed noise. Now in the VOP noise here, we're gonna add the noise, the actual noise to resemble like the electricity. How we do this is with a couple of notes here, nothing really that hard, to be honest. We're gonna pipe the color into a new ramp. Since we know that the color goes from 0 to 1, and the ramp takes values between 0 and 1, that's fine. So we're gonna pipe the color into a ramp that goes between 0 and 1. And what we actually want to do with this ramp is that we want to define kind of where the noise should be and where it shouldn't be. So let's dive up actually for the moment and take a look. The ramp we can see here doesn't actually go from black to white. It goes from black to white to black again. And this means that if you think of this as a ramp, how you gonna explain it? So if you think of this as a ramp, the black here is one of the endpoints, the black here is one of the endpoints, and the white here is the middle of the curve of the line, right? So if I move this, we can clearly see the noise moves, but the endpoint still stays in place. This means that this is now our new color value. We can use this in the amplitude of noise. And as you remember, black is 0, 0, 0, white is 1, 1, 1, and black again is 0, 0, 0. The amplitude can therefore be modified with these color values. So any point that has the color value of white will get an amplitude of 1, while any point that has the color value of black gets an amplitude of 0. Therefore, we want to pipe this ramp right here into our noise. So here's a turbulent noise. I'm going to pipe this ramp into our amplitude, which means some points will get an amplitude of 1. Some of the points that are black will get an amplitude of 0, defined by this ramp. Okay. The noise, nothing fancy here. Just put the frequency a little bit higher, put it to 3D noise, and put it to alligator noise. That's it. We want to add this noise onto the original position of the line. So we do an add. We put the position into the first input, the noise into the second input, and we put the sum of this into the position update. Okay. And this means if I disconnect this, if we put it, we can now see the line has noise. And the amplitude is defined by this. So let's go out here and try something. So these ends are both 0, which means that here and here, the amplitude is 0. In the middle here, we although have the amplitude of 1. What if I wanted the amplitude to be, let's say 5 instead? I can actually define that in the color here. So instead of writing 1, 1, 1, we can write 5, 5, 5. And you can see the amplitude goes crazy of the noise. Let's type 2, 2, 2. You can see it's bigger. And let's go back to 1, 1, 1. And it's back to normal. So that's kind of how we can use a ramp like this to modify each point's amplitude in a noise. Okay. Now we also want to do something else. We want to do something cool. So later on, we're going to wrap this line in polygons. And we're going to use a thing called a polywire right here. But we also want to define kind of how thick this polywire or the surrounding area of this line is going to be. Okay. And what we can do is we can create a completely new attribute that will define this. So as we know, if we pipe this ramp into color, we can see that this end is black, this end is black, and here's white. We can use this as a width attribute. So anything that is black will get a width attribute of 0, And anything that's white will get the width attribute as 1. And anything in between will get all the values in between. So let's say we take this area right here. Let's put on the point. Let's say the area right here. Maybe this point right here has a 0.4. Maybe this one has 0.7. This one is 0.9. And here it's 1. Okay? This means we can pipe this ramp into a completely new attribute. We're going to disconnect the color. Into a completely new attribute we can call width. And we're going to put the width to a float value. And later on, we're going to use this width to actually define how thick the poly wire is going to be. Okay? So everything in here is done. We have kind of created a line with the noise and stuff like this. We're just going to add a smooth afterwards to kind of smooth it out a little bit. Just smoothing iterations to 3. And we're going to smooth the position. We're going to go down and we're going to add a poly wire. Here is where we actually wrap this thing in polygons, okay? Wow, so actually, as you can see here, it actually gets thinner here and thicker here. And that's because we put in the wire radius, we put this. We put add width, and then we can do a multiplier, like times 1. You're gonna see it gets super thick here, but still retains a 0 in the ends. I'm gonna put 0.3, okay. So that's how we can use an attribute to kind of define the width of this poly wire. And it's really cool. I use this a lot in production. I've done a lot of like electrical type things, and this is something I use a lot. Like the width attribute is super useful for the poly wire. And the ramp way to control the amplitude is also very useful. But we have done a lot of things here. We have calculated the distance, we have done the noise, we have done resampling. There's an easier way to do all of this. And I kind of wanted to just go through this to kind of just prove a point, to kind of teach you guys how to use distance, VOP and stuff like this. But how you can actually do it instead is we can create a line here, okay? It's when we put 87 points, because remember we had 87 points in here after we resample it. We're going to put it the same length, so 1.4. So the points are the same now. We're going to use a node called the UV texture. And we're going to put the texture type to rows and columns. And we're going to put the attribute class to points. What this will do, it will actually create that ramp for us that the distance did. And what I'm going to do is I'm going to prove this by adding a color. So we're going to do a color and a ramp from attributes. And we're going to put UV. And as you can see, it doesn't go from black to white, but it does go from green to yellow and actually to red over here. And this means that we actually do have a value from 0 to 1 across this line. And this means we can do the exact same thing with skipping both of these steps right here with just a single node, which is really cool and useful to do things faster. And then we're gonna do the same thing here in like in the VOP. We're gonna do the ramp from these values. So the ramp grabs the UV attribute that is 0 to 1. It remaps that and ramps it the same way as we did before. Right here with black, white to black. We put that ramp into the amplitude of the turbulent noise. And we add the turbulent noise on top of the original position. We do the width attribute from the ramp. So we have everything the same, but it's a lot faster and just a lot simpler, honestly. We're gonna smooth it out. We're gonna do here, and we're gonna switch to the second input of the switch. So now we're doing this stream instead of this one. We're gonna do the polywire, and voila, same result, just way faster. So yeah, there's just two different ways you can do noise. This one is obviously much simpler and much easier, but it's still good to know how to do like the distance and like this kind of things. But yeah, okay, that's a little bit longer and more advanced tutorial. Hope you guys enjoyed it, and I'll see you guys in the next one. Thank you.